A very good afternoon to you all. Thank you for attending part 2 of our Windows and Facades Coffee Chat series. Today's presentation is going to be about the awkward truth about fire-rated membranes, brought to you by Mr. Rob Halliwell. And please feel free to ask questions throughout. They will go into our little questions box, and Rob will answer all questions at the end of the webinar. So I hope you enjoy today's presentation, and without further ado, I'm going to hand you over to Rob.
Good afternoon. The first question we have to ask ourselves is, what is the purpose of a membrane and what is it required to do? The use of membranes is inevitable and they are required to fulfill certain basic functions to a high standard. Membranes are required to fulfill the needs of accredited construction details and part of the building regulations. The primary performance considerations of membranes were well established before the 2018-19 changes to Part B4, Regulation 7 of Approved Document B. And unfortunately, it's come to our attention that many professionals, including consultants, fire engineers, insurers, specifiers, warranty providers, and main contractors, are still somewhat confused about what the regulations actually state and what is possible to achieve. Even if this does sound a little harsh, the professionals in reality should know a little better because we place our trust in them. Now, colloquial and familiar terminology is leading to an over-expectation and some suppliers perpetuating a number of myths through the misuse of incorrect or invalid terminology, or even misleading headline marketing fluff concerning this subject. Now, as far as primary functions are concerned, hopefully we all agree on what a membrane should be able to do. Unfortunately, there appears to be a recurring common misunderstanding or assumption that membranes with lowered combustibility or with certain reactions to fire above Class B or better have the ability to provide a barrier against the spread of flame. This is simply not possible. Why? To establish a fire rating, specimen products and applications are assessed according to one or more of the above standards. Membranes and tapes are beyond the standard scope of assessment for the established standards of methods of testing for BS 476 Part 2022, BS EN 1366 Part 3 and 4, BS 135 and BS 8414. Now, the starting point for all assessments is the R factor, which equals structural stability. If no structural stability exists, then the assessment cannot take place. For structural integrity to be established, the substrates that support the application and or the immediately adjacent to it must have a known low reaction to fire, e.g. should be of confirmed low combustibility or completely non-combustible. During assessments, the test specimen must demonstrate that it can maintain fire integrity, referred to as E, during the fire, and that it can insulate against fire, referred to as I insulation. Insulation means that fire cannot be propagated on the opposite face of the substrate that's being attacked by the fire. Assuming the assessment is successful, the results are measured in time, X minutes integrity and X minutes insulation. Now, concerning membranes applied to windows and construction joints, it's known that membranes have no integrity or insulation properties. They rapidly degrade or disintegrate when impinged by flame, usually in less than 20 minutes, well below the threshold of a minimum EI 3030 rating. Furthermore, the adhesives used to bond and seal the membranes in place may continue to spread flame after the membrane has disintegrated. Window frames melt or deform due to heat between 300 and 600 degrees in round figures, and glass shatters above 150 degrees centigrade. Fire at the point of flashover is above 900 degrees centigrade. So external windows simply cannot handle fire. Therefore, membranes, the window frames, window glass, door frames and door glass cannot provide the structural integrity R. In recognition of this, external window frames, window glass, door frames and door glass are exempt from Regulation 7 altogether. There is no known standard or criteria under which membranes can be assessed for the purposes of achieving an EI rating. Approved Document B recognises this and states that membranes applied to the outside walls should achieve a minimum reaction to fire of Class B S3D0 according to the harmonised standard 13501-1. The standard 13501-1 is not a fire rating. It is a classification only and should not be referred to as a rating in any way at all. The required specified minimum reaction to fire applies only to relevant buildings and not all buildings. As highlighted earlier, familiar phrases in terms of reference play a major part in misinterpretation of fire regulations, which so very often leads to confusion, misinformation, assumptions, and over-expectations. Furthermore, several material suppliers have further perpetuated certain misleading, erroneous name culture, which has apparently normalized the use of inappropriate and invalid terms of reference. So to be absolutely clear, there's no such thing as a non-combustible EPDM, fire-rated EPDMs or membranes, fire-rated window breather or vapor barrier membrane systems, fire-rated tapes, non-combustible tapes or membranes, or fire-rated or non-combustible adhesives. Avoid these or any similar terms of reference at all costs, and avoid a supplier that promotes their products with similar straplines. These things are just not possible, and as such statements are irresponsible and untrue. Products that meet the Class A2 and Class B reaction to fire are not non-combustible. Facade engineers, facade consultants and the like should be intimately familiar with the reaction to fire classifications and what they actually mean. Only a material with a Class A1 reaction to fire is truly non-combustible. There's no legal or moral imperative to apply membranes with a Class A2 S1D0 reaction to fire. If you read the relevant part of Regulation 7, you will see in black and white that the membranes are exempt from the Class A2 requirement altogether. Hence, they are required to be no worse than Class B. Therefore, that when we hear of a consultant or engineer has insisted or decreed that all materials must be Class 2, we can see that said person simply does not have full understanding of a very simple set of requirements, has possibly misinterpreted or maybe overreaching in some way, but all for the right reasons. Yes, it is quite true that the majority of materials applied to the external wall should be able to achieve a minimum of Class A2 S1D0, but for those items that are exempt altogether or are expected to achieve a different reaction to fire, it's a different story. It is appreciated that it may well be desirable to apply a product that has an improved reaction to fire of Class A2, but those that are claimed to be Class A2 or better than Class B systems, are they actually capable of achieving and maintaining not only the reaction to fire, but more importantly, their primary functions? It may be comforting to know that should the worst happen, the product won't burn easily or at all, but it would be pointless to apply it if it didn't perform its everyday functions to a high standard. For example, a breather membrane that is less than watertight, or one that cannot breathe, is less than useful, and a vapor barrier that maybe barely meets the minimum vapor resistance required under Part L is less than an effective barrier. Now, these are just a couple of the major considerations that need to be acknowledged, but are very often overlooked in favour of the purported reaction to fire. The datasheet or agreement certificate is not always the guarantee of performance. When presented with the Class A2 option, the person reviewing does not always appear to have the necessary knowledge concerning the methods of testing, not only for fire, but also for the resistance to liquid water penetration, air and vapor permeability, or other considerations too. The first question one should ask themselves is how and where the assessments were performed, and were they compliant with the methods of testing? There are a limited number of Class A2 membranes available, and the adhesive products that are available, but are the A2 classification only valid? Because they would only be valid as a system if the membrane and adhesive was tested in combination. When adhesives are used to secure or seal a membrane, the two items must be tested together, not separately. The test standards are very clear about this, and it's a primary prerequisite, clearly outlined within the methods of testing documents. Where membrane requires an adhesive to bond it to a substrate, the two must be tested together in the same proportions as would be required to affix the product in a live application. This is also true if the product supplier has tested the adhesive separately, either by error or deliberation. Where this has unfortunately occurred, the proportions should have been representative of an on-site application and not thinned out. For example, smearing an adhesive over a Class A2 backing board at the rate of 180 grams per square metre means that the dry film may be no more than 130 microns thick, and when impinged by flame, the adhesive is likely to burn away quickly, exposing the surface of the backing board behind that already has a low combustibility. Thus, the results of a 20-minute test could potentially be compromised and provide a false positive outcome. This is particularly noteworthy when in reality the product supplier clearly advocates that the adhesive should be applied at a rate that equates to 1 kilogram per linear meter in their method statement. This is much higher than the tested sample, and clearly the behaviour is likely to be quite different in a real-life fire scenario. If a membrane and adhesive are tested separately, the individual results do not constitute an overall reaction to fire. A separately tested Class A2 membrane bonded with purported Class B adhesive is not a Class A2 system. A separately tested Class A2 membrane bonded with purported Class A2 adhesive is not a Class A2 system unless tested together. This also applies to other Class B products as well if they've not been tested in combination. So, first and foremost, consider the primary functionality. It rains on buildings, and buildings are more prone to leaks of all kinds more than they catch fire. That's not making light of the situation, of course. Reaction to fire is a secondary compliance consideration for relevant buildings only. Many of the Class A2 options are less than capable of providing primary functionality. Many of the Class 2 options have not been assessed for reaction to fire in strict accordance with the methods of testing. Many of the Class 2 options require more adhesive to affect the actual application than have been tested. It is the cured adhesive residue that constitutes the higher risk. The use of adhesive should be adequate and not excessive. The reaction to fire won't provide a fire barrier. Membranes are not passive fire-stopping solutions. When choosing a Class A2 membrane, be prepared for a potential hike in material consumption and associated costs. There's been such a rush to get membrane products to the market since 2018 that meet the minimum or better than Class B primary functionality, and the primary functionality is being routinely overlooked and potentially misunderstood. We recommend that you draw up simple checklists so that you can compare performance in an informed way. When considering an apparent Class A2 or Class B membrane and adhesive system, ask the supplier for a full test report that clearly demonstrates that the adhesive has been tested in combination with the membrane. Test certificate or an Agrimon certificate alone may not provide the required evidence. Does the report show the tested proportions of adhesive, and do they match the supplier's method statement? Remember, the adhesive is the potential risk. Some pointers. A Class W1 resistance to liquid water penetration means that liquid water cannot pass, whereas a Class W2 membrane does allow some water to pass. Ask yourself if this is suitable for a high-rise building with hundreds of square meters of facade. At least verify that the window membrane material is airtight to at least one of the recognizable standards for airtightness. External membranes need to be breathable, and internal membrane needs to be airtight. Are you familiar with the standards and all that entails? An external membrane with the vapor resistance of an equivalent thickness layer of around 13 meters is neither vapor open enough to be breathable or vapor closed enough to be considered a vapor barrier. Would a membrane matching this performance be truly suited for use as an external perimeter seal where vapor permeability is required? Another thing to check perhaps is UV stability, generally covered under the standard EN 13859. Potentially look for membranes which have UV resistance for at least 9 months or perhaps are even permanent. What if the building was to be delayed or materials have to be stored off-site exposed to weather and other elements for a long period of time before they can be applied? So we've given you some of the relevant standards and the minimum functional criteria for a membrane to be considered fit for purpose, given their location within the built-up wall. So let's chat.
Thanks very much, Rob. It doesn't look as though we've had any questions so far, but we can hang on for another couple of minutes in case anyone does have any questions. And if you don't think of any at the moment, feel free to get in touch with Rob directly via email at rob.halliwell@ cpg-europe.com, where he'll be more than happy to answer any queries that you may have. Yeah, there's nothing coming through there at the moment, Rob.
No.
Someone's raised their hand. Let's have a look. Okay, well, we shall wrap it up there, guys. Thank you very much for attending today, and please feel free to reach out to Rob directly with any questions that you may have. Thank you.